You're sitting on the couch. You haven't moved. You haven't reached for your keys. You haven't even decided to go outside yet, but your dog is already at the front door, tail wagging, eyes locked on the handle, waiting. You turn around and ask the question every dog owner has asked at least once. How do you know? And you're not alone. Millions of owners experience this exact moment every single day, each time feeling like their dog just read their mind. Most people call it a sixth sense. Some even say their dog is psychic. But behavioral science has uncovered the real answer. And it's more extraordinary than anything supernatural, because it's actually real. In 2017, researchers at the University of Portsmouth ran a groundbreaking series of experiments on how dogs interpret human movement. Kaminsky and her team wanted to understand what dogs actually see when they watch us. What they found was striking. Dogs don't simply react to your actions. They read your preparatory actions, the extremely subtle movements your body makes before the main behavior begins, the micro shifts in posture and muscle tension you don't even realize you're making. Long before you stand up, your dog has already read the prelude. Think about what happens before you walk to the door. You shift your weight on the couch. Your breathing changes. Your eyes drift toward the hallway. You think you made that decision in a split second, but your body started broadcasting it minutes ago, and your dog was reading the entire broadcast. But here's where it gets deeper. In 2015, Muller and colleagues tested just how sensitive dogs are to human body orientation. The result? Extraordinary. Dogs detected shoulder rotations as small as 10 to 15 degrees, not a wave, not a slight turn of your shoulders, and your dog already knows exactly which direction you're heading. And here's what makes this ability even more remarkable. In 2012, Lakatos and colleagues ran a comparative study across species. Dogs outperform chimpanzees at following human communicative gestures. Chimpanzees, the species closest to us genetically, our nearest evolutionary relatives. Your dog reads your body language more accurately, sight, than a primate that shares 98% of your DNA. But vision is only the first layer. The next one goes much deeper, and it starts with their nose. Jeannie C. Alexandra Horowitz, in her 2009 work Inside of a Dog, documented something most people never stop to consider. A dog's olfactory system is 10,000 to 100,000 times more powerful than yours. That's not a metaphor. That's measured biology. When you shift from rest to activity, the chemical composition on your skin changes. Subtle shifts in adrenaline, minute traces of cortisol, metabolic byproducts you can't see or feel. Your dog smells that entire transition before you've even registered the decision to move. And here's the part that surprised even researchers. The moment you start thinking about doing something, your cortisol and adrenaline shift. You can't feel it, you can't see it, but your dog's nose picks it up, like a signal flare in the dark. But here's where smell gets truly extraordinary. Kokochichka, your scent in the house, the one you left behind when you went to work, fades in a pattern your dog has learned through repetition. When it drops to a specific threshold, the one that matches your usual return time, they know. You're about to walk through that door, so your dog sees you and smells you. But there's one more channel you probably haven't considered. Their ears. In 2007, Adachi and colleagues at Kyoto University demonstrated something remarkable. Dogs have cross-modal recognition. They hear a voice and automatically generate an expectation of whose face should appear. When researchers played an owner's voice but showed a stranger's face on screen, dogs stared significantly longer. Much longer. They were surprised. The auditory prediction their brain had generated didn't match what their eyes were seeing. Your dog recognizes the sound of your car from 2 blocks away, the jingle of your specific keys, even the rhythm of your slippers on the floor. Each sound is a puzzle piece in their prediction map, and all 3 systems, eyes, nose, and ears, don't work in isolation. They run simultaneously, feeding data into one unified model of what you're about to do. But those 3 senses are just data collection tools. What truly operates behind them is something many researchers didn't expect dogs to possess, an awareness, too, of time itself. 2. Roberts and colleagues published findings in 2008 that challenge how we think about dog cognition. Dogs have circadian rhythm systems remarkably similar to our own. Their brains track the time of day and link specific times to recurring events, building internal structures researchers describe as temporal maps. Your dog doesn't just react to events, they anticipate them, based on when those events usually occur. And here's the data that confirms it. In 2011, Wren and Keeling at the Swedish University of Agricultural Sciences tested how dogs respond to different durations of owner absence. The results were unambiguous. Dogs greeted their owners with significantly different intensity after 30 minutes compared to 2 hours, and different intensity again after 4 hours. They don't just know you left, they track how long you've been gone. Think about what this means for your daily life. Your dog has a detailed time map of your entire day. 7:15, you turn off the alarm. 7:20, you walk to the kitchen. 7:45, you reach for your keys. 7:50, you tie your shoes. Every step is encoded in memory, and when even one step happens a few minutes earlier or later than expected, your dog notices because the map doesn't match. But collecting sensory data and tracking time still doesn't answer the deepest question. How does your dog seem to know what you're about to understand that? You need to look at their pattern-matching brain. GDC in 2020, Fugaza and her team at AUTVOS Lorand University in Budapest uncovered something remarkable. Dogs exhibit what researchers call Qi predictive gaze. They don't just follow where you go, they look ahead to where you're about to go. This is the same cognitive ability observed in 12-month-old human infants. Babies learn to predict what adults will do next. Your dog's brain runs that same simulation every single day before the event even happens. And here's where it gets even deeper. Duranton and Gane published research in 2015 documenting behavioral synchronization. Over time, dogs don't just observe your routines, they synchronize with them. They build internal predictive models that map every sequence you repeat. When you do A, next is always B, then C. After thousands of repetitions over months and years, that chain becomes automatic. Your dog runs the sequence before you do. But what truly powers this prediction system is a memory capability researchers once doubted dogs had. In 2016, Fugaza and colleagues used a paradigm called Do As I Do to demonstrate that dogs possess episodic-like memory. They don't just form habits, they remember specific past events, what happened, where it happened, and when. That's not reflexive behavior, that's recall. So your dog isn't just reacting to what you're doing right now. They remember the sequence from yesterday, and the day before, and the hundreds of days before that. They predict what comes next, like a pattern recognition system trained on thousands of repetitions of your daily life. And here's the part that made many researchers pause. In 2011, Litt and colleagues demonstrated something unsettling, but profound. Even professional dog handlers, people specifically trained to remain neutral, still unconsciously leak information through their body that dogs read perfectly. They call it the Clever Hans effect, named after a horse in the early 1900s that appeared to solve mathematics, but was actually reading invisible cues from his handler's body. Unconscious cueing. You think you're sitting perfectly still, but your heart rate shifts, your pupils dilate, your muscles tense in patterns so subtle, no human observer would notice. Your dog reads every one of them, every micro-expression, every chemical shift. You are an open book to your dog, and they have spent years studying your specific addition. But here's a question almost nobody thinks to ask. Why are dogs so extraordinarily good at reading humans? Better than any other species on Earth? The answer goes back 15,000 years. In 2002, Hare and colleagues at Harvard and the Max Planck Institute proposed what's now known as the domestication hypothesis. During the long process of domestication, dogs that read human signals better had a clear survival advantage. They were fed more, protected more. They survived to reproduce. Over thousands of generations, natural selection favored the individuals that could decode human intention. Research suggests this ability isn't simply learned behavior. It was shaped through evolutionary pressure. And the genetic evidence supports this. Person and colleagues analyzed ancient DNA in 2015 and found that 15,000 years of living alongside humans created measurable selection pressure on genes linked to social cognition. The dogs alive today carry genetic architecture shaped specifically for reading human behavior. In a very real sense, evolution designed them for exactly this. Your dog's ancestors survived because they correctly predicted what humans would do next. The ones that couldn't read us didn't make it. The dog sitting at your front door right now, the one who seems to read your mind, carries that same 15,000-year algorithm. It's not a party trick. Read your intention. If you say sit, but your body is already leaning toward the door, they'll follow your body, not your words, because your body has never lied to them. Your words sometimes have. Now, one important signal worth knowing. If your dog suddenly loses the ability to predict familiar routines, if they seem confused by sequences they used to anticipate that change could reflect several things: environmental disruption, stress, or in some cases, early signs of cognitive decline, canine cognitive dysfunction. If the change persists, it's worth a conversation with your vet, especially in older dogs. Nielsen and colleagues found in 2001 that 28% of dogs aged 11 to 12 and 68% of dogs aged 15 to 16 show at least one sign of cognitive dysfunction. Loss of routine prediction. The inability to anticipate what comes next in a sequence they've known for years is one of the earliest indicators. See NIME. But in a healthy dog, this prediction system runs every single day, quietly, effortlessly. So the next time you're sitting on the couch, you haven't moved a muscle, and your dog is already at the door, tail wagging, waiting. Chapter: A brain running 15,000 years of evolutionary algorithms, all at once, in silence. Faster than your own consciousness. In a language we can understand, their behavior says one thing: you are their favorite book, and they have memorized you by heart.